Okay, so now we'll move on to matrix arithmetic. So matrix arithmetic will be covering addition, subtraction, and multiplication of matrices. So addition and subtraction are pretty straightforward. Just a few rules that you need to sort of memorize or sort of know is that if you're adding or subtracting matrices, you need to have the same order of matrices. So the matrices need to have the same order. So for example, in this question, we have a, so 2 rows, so 2 by 3 matrix, and then we're adding it to a 2 by 3 matrix. So since these two matrices have the same order, they can be added. So when you're doing matrix addition and subtraction, the first thing to know or to sort of find out is if the matrices that you're adding or subtracting have the same order. If they don't have the same order, then the addition or subtraction cannot actually be done. So in matrix and matrix addition and matrix subtraction, all that we're doing is we're adding the elements in the same position in the 2 matrices or the 3 matrices that you're adding. So for example, when we're adding these 2 matrices, what we're doing is we're adding the elements in the same position. So for example, in position 1, 1, or first column, first row, we're adding that to the element in the first column and first row of the other matrix. So these 2 elements will be added together, and the final matrix will also have the same order as the 2 matrices that you're adding. So this will also be a 2 by 3 matrix. And essentially, when you add these 2 numbers, so 3 and 3, in the same position on both of the matrices, the final or the sum is going to be in the same position as well. And it's just going to be the addition of these 2 elements. So 3 plus 3 gives you 6. Similarly, if we were to add the elements in the first row and second column, so 7 in this matrix and 9 in this matrix, so 7 plus 9 would equal to 16. And that would be in the same position as these 2 elements in the new matrix. So pretty straightforward. We're just adding the elements in the same position when we're adding matrices, and that will be the new position or the position of the sum of the 2 numbers. Same for subtraction. So subtraction is exactly the same. So if this was subtraction instead, we would just do 3 minus 3 instead of 3 plus 3, and the position would just be row 1 and column 1 for the answer, which would be 0 in this case. And that's how you would do matrix addition and subtraction. So let me know if you have any questions so far in the chat. Okay, so next we'll move on to matrix multiplication. So matrix multiplication is a little bit different, but essentially it can be done on your CAS, and Rika will usually most of the time won't really expect you to do it by hand, but it's really important to be able to do it by hand because, and I'll show you why that's the case. So we'll only be doing matrix multiplication because matrix division cannot be done. It's not really a function that can really be done from matrices. There's another way that we can sort of technically divide matrices, but it's not conventional as dividing 2 numbers. It's like 8 and 2. If we were to divide 8 by 2 to get 4, it's not as simple as that. So we'll get to that later. Okay, so when you're multiplying matrices, there's essentially 2 rules that you need to sort of work out before you start the actual multiplying. So the first thing is that the order for the order of the matrix multiplication needs to be sort of worked out. So you need to work out the order of the 2 matrices that you're multiplying before you do the actual multiplication. And the essential rule is that the number of columns in the first matrix must equal to the number of rows in the second matrix. So this is really important. So essentially, if we had matrix A and we wanted to multiply it by matrix B, the other way around, B times A. Okay, another thing that you need to remember, sort of understand is that multiplying matrix B by by A is not the same as A times B. So A times B is not the same as B times A. The order is so important. And I'll show you why in a second. So if we were to multiply matrix B by matrix A, what we would do is we would find the order of both of the matrices. So for matrix B, it's just 2 rows and 1 column. So 2 by 1. And then what we do is we put an X in the middle, and then we write the order of the second matrix. So second matrix is A, which is a 2 by 2 matrix. So once we write it in this form, so the order of the first matrix multiplied, or not multiplied, but X, the second matrix, the order of the second matrix. Then what we do is we put brackets around the inside numbers. So around this number and around this number, we would put a bracket. And now what you need to check is if these two numbers are the same. So in this case, these two numbers are not the same. So we have a 1 and we have a 2. So that's not the same. So what that tells you is that the matrix multiplication cannot be performed. So the answer is going to be undefined, or it just can't or you just can't do the matrix multiplication. And that's because the number of columns, so 1 represents the number of columns in matrix B, in the first matrix, must equal the number of rows, which is 2, in the second matrix. And if it's not the same, then the matrix multiplication cannot be performed. So that's the first rule. So if we were to do A multiplied by B instead, so then we write the matrix, the order of matrix A first, so 2 by 2, X, the order of matrix B, 2 by 1, and then we put the brackets inside the around the inside numbers. So that would be 2 and 2. So in this case, they're both the same. And since they're both the same, we can perform this matrix multiplication. So that's the way that you need to verify if the matrix multiplication can be performed or not before actually doing anything else. Okay, so that was the first rule essentially. The second rule is that if the matrix multiplication can be performed, and that the number of columns in the first matrix is equal to the number of rows in the second matrix, so 2 times 2, if it's the same number, the second rule states that the number of rows is going to be the same as the first matrix, and the number of columns is going to be the same as the second matrix. So the outside numbers, so the numbers that are not put in the brackets, are going to be the new order. So the new order of this matrix, so once the multiplication has occurred, is going to be 2 times 1. So multiplication is a little bit different to addition or subtraction. You're not just going to multiply the numbers in the same position. It's a little bit different. You need to sort of use these two rules before you do the matrix multiplication. So first step is working out if the matrix multiplication can even be performed by writing down the order in this form and then putting a bracket inside the inside two numbers. So in this case, if it's going to be 2 by 2, that means the matrix multiplication can be performed. And then the order is just going to be the outside numbers. Okay, let me know if you have any questions. Okay, so now we're actually going to do the matrix multiplication. So in the previous question, we verified that the matrix multiplication will exist if we multiply A by B. So now we will do the actual matrix multiplication. Excuse me. So the actual process for multiplying is a little bit weird when you first start doing it. But once you start doing it, it becomes really easy. So the way that we do matrix multiplication is we take the numbers in the first row and we'll multiply that by the numbers in the first column of the second matrix. So what we do is we do 1 times by 5. So the number in the first row of the first column multiplied by the first number in the first row of the first column in the second matrix. And then we take the number in the second column. And then we multiply by the number in the second row. And then we add those two together. So 1 times 5 added by 3 times by 6. And that becomes the new element in the first row and first column of the product matrix. And then once we've done that, we do the exact same process. So we take the numbers in the second row and then multiply by the numbers in the first column. So if there's multiple columns, you'll have to do this process a few times. But essentially, first row times first column, second row times first column, then first row times if there's a second column, second row times second column, and so on. So this can get really messy really quickly. So that's why it would be beneficial if you could do this on your calculator. And VCA will usually expect you to do it on your calculator, except for a sort of few times when they actually ask you, instead of asking, okay, so the thing is, VCA can't actually really verify if you've done it on your CAS or by hand. So there's no actual point in putting in a question which asks you to do it by hand, because they don't actually, like, it's usually most of the questions in the exam are 1 mark, or 2 marks most of the time. And they're really, what they're going to be doing is just asking you to, if they give you these two matrices, just work out what this matrix is. So just write the actual final answer using a calculator. But what VCA likes to do in order to test this is what they'll ask you to do is say, how did you find this element? And then is when you will show this particular working out. So 2 times 5 plus 4 times 6. So if they were to ask you, how did you calculate element? So let's just say this product matrix was called A. And they would ask you to work out, how did you find our element, element 2, 1. So element 2, so element in row 2, column 1 of the product matrix. And they ask you to show your working out of how you found this element in the product matrix. So in that case, you would need to show this working out over here. So 2 times 5 plus 4 times 6. And that is how they can verify that you've done this by hand. Or well, not by hand, but that you know your sort of principles of matrix multiplication. If you have any questions, let me know in the chat. We're going to move on to summing matrices. So matrix multiplication is really important. And basically, you need to follow those 2 rules at the beginning to verify if the matrix multiplication exists. And if it exists, you can either use your calculator or just use the process that I've just went through. But the process can get really complicated sometimes. So prefer to use your calculator, but also keeping it at the back of your mind of how you would do it by hand, in case there's a question like the one that I just showed you. Okay, so next we'll move on to summing matrices. So these are essentially matrices that we will use if we wanted to, for example, add up the numbers in a particular row or a particular column. So if we wanted to add the values of the numbers in a particular row, we would use a row summing matrix. And a row summing matrix is essentially a column matrix that just contains ones. So the elements are just ones, and the amount of and the size of the column matrix that you would use is dependent on the size of the original matrix that you're trying to sum up. So what I mean by that is, if the numbers in each row, if there's 2 numbers in each row, then the row summing matrix that you're going to be needing will have 2 rows as well. And since it's a column matrix, it's only going to contain 1 column. So only contain 1 column, all the elements are going to be 1, and the number of rows is going to be the same as the number of sort of columns in this matrix, because you're going to add up 4 and 5, so the number in each row, so you'll need 2 elements in the row summing matrix. And the specific order of where you place this matrix is really important. So you can't do 1, 1 times by this matrix. So if you're using a row summing matrix, you'll need to put it after the matrix that you want to sum up the rows for. So yeah, you do the row summing matrix and then multiply by the column matrix. So the order is really important. However, if you want to sum up the columns, so 4, 8, 9, 5, 1, 0, if you want to add that up, what we would do instead is use a row matrix. So the row matrix would have the same number of columns as the number of rows that you want to add up. So in this case, we want to add up 1, 2, 3 rows. So therefore, there will be 3 elements in the column summing matrix or the row matrix, but only 1 row. And this time, the column summing matrix will need to be placed in front of the matrix that you want to add the columns for. So that's really important. Jot this down somewhere in your summary book, and you should be really good to go. Okay, so now we'll have a look at scalar multiplication. So scalar multiplication is a little bit different than matrix multiplication, because in scalar multiplication, you're multiplying the matrix by just one number. And it's a scalar, it's not a matrix. So for example, just multiplying this matrix by 1.2, for example, that would be scalar multiplication. However, if this was a matrix, so a matrix multiplied by a matrix, then that would be matrix multiplication. And you would have to use the other method that we just went through a few slides back. So when you're doing scalar multiplication, all you need to do is multiply each element by the number, by the scalar, essentially. So for example, here the scalar is 1.2, so you'll need to multiply each element by 1.2, and that will be your product matrix. And the sort of uses of scalar multiplication are usually financial reasons. So for example, if we have a particular item at a store and we want to mark up the price by 20%, we might use a scalar multiplication. So for example, if we had the values or the the prices of the items in a matrix. So like I said, matrices are just another way of representing information. So if we had the prices of various items in a store in a matrix, and we want to mark up the price, we can just use a scalar multiplication, or a scalar, so 1.2 in this case, because we want to mark up the price by 20%. And that will give us the new price. So sort of similar to, if we go all the way back to Unit 3, sort of similar to seasonal indices. So very similar to that. And then another thing that you need to know is matrix powers. So that is when so this is probably not that often. You won't see this very often, but just in case, if we're putting a matrix to a power of something, so for example, a to the power of 2 or a to the power of 3, it's not just as simple as putting all the numbers in the element to the power of 3. Because if you remember back to high school, or back to the beginning of high school, if you're doing 2 to the power of, let's just say 3, that's not just, so that's actually equal to 2 times 2 times 2. So if we're doing a matrix, for example, a to the power of 3, that would actually be matrix A times matrix A times matrix A. So just really important, but most of the time this will all be done on your CAS. So just in case there's a question where you have to do it by hand, this is what it actually means. Okay. So now we'll talk about permutation matrices. So like I said, permutation matrices are really important in the course. But the main uses of permutation matrices in matrix arithmetic is usually to manipulate a particular matrix without actually changing the elements. So usually what we use a permutation matrix for is to change the order of a matrix. Sorry, not the order, but the order of the elements in the matrix. For example, if we have in this matrix rat, and instead we want tar, In order to change that order using some form of matrix method, we would need to use a permutation matrix. And usually what VCA likes to assess in terms of this topic is they will give you a matrix and they will ask you to find the permutation matrix that will take you to the new matrix, or whatever they asked you to find. And this is a little bit of CAS, so you need to be really good at using your CAS for this. And it's also a little bit of trial and error. Like there's no specific method, I would say, that you would use, that you would sort of use to do this question. It's a lot of trial and error. But the way that I like to sort of do these types of questions is I like to write from and to in my matrix. So from and to. So the way that I like to sort of work with this is if I have a particular permutation matrix. So remember, a permutation matrix is always a square matrix and it only contains 1, 1 in each row in each column. It's different to a binary matrix because binary matrices just contain zeros and ones. They might have more than one in each row or each column, but a permutation matrix will only contain 1 in each row and each column. So, for example, the way that I like to think it is if we have something in row 1 and we want to change it to column 3, we want to place the 1 in the third column because we want to place it in the third row. So the way that this would sort of work in terms of matrix multiplication is, if you think about it, it's going to be 0 times R, 0 times A, plus 1 times T. So therefore, T would be placed in the first row of the new matrix. Similarly, we have 0, 1, 0. So 1 is in the middle, or in the second column. So therefore, A would be placed in the second column of the new matrix. So it will retain its position. Whereas for this one, in the third row, we have 1 in the first column. So therefore, R will be placed in the third row instead. So this number, so wherever the 1 is, would indicate where the number would go. So for example, in this matrix, in the first column, we have a 1 in the third row. So therefore, R, which is in the first row, would go into the third row. Similarly, we have A in the second column and the second row. So therefore, it would go in the second row of the final matrix. And T, which is in the, so we have a 1 here, which is in the first row and third column. So therefore, T would go into the first row. So a little bit of trial and error if you're using your CAS. So try doing a lot of various different permutation matrices. Try multiplying it with RAT to get to TAR. So a lot of trial and error. But you will eventually get some. So this is not something that would be really hard, but something important to know is that you're using a permutation matrix. And the permutation matrix is actually, when you're multiplying it, it comes before the matrix that you want to change the order of. So just a few important things to know if you are going to be using trial and error. Okay, so next we move on to matrix equations. So matrix equations is essentially another way of dividing matrices. So like I said, you can't divide matrices. There's a different method that you will use in order to divide matrices, but we're essentially not dividing, as you will see very soon. And there's something called matrix equations. So for example, if we had A times X is equal to B. So let's just say they're not matrices, they're just not common letters. So if we want to find X, all we will need to do is divide by A on the right-hand side. But we can't actually do that in terms of matrices. So we'll have to use a different method, and that's called matrix inverses. So we'll need to find the inverse of this matrix and then multiply the matrix here by the inverse of this matrix in order to find what X is. It's a little bit complicated, but I'll try and break it down. Okay. So first step is finding the determinant matrix. So the determinant of a matrix. So the way that you would find the determinant of a matrix is by using this particular formula. So A times D minus B times C. So and for the purposes of General Maths 3-4, you'll only be finding the determinants of 4 by 2 by 2 matrices. So square matrices that are 2 by 2. You can, on your CAS, however, find the determinants for 3 by 3 matrices, but VCA won't be testing that. They'll only be testing the determinants for 2 by 2 matrices. So you will label your elements. So for example, if you had this matrix over here, so if you had this matrix over here, so 2, 3, 4, 5, you will then have to label your matrix. So 2 will be A, 4 will be B, 3 will be C, and 5 will be D. So once you've done that, then you can use a formula. So determinant is just A times D, so 2 times 5, minus B, which is 4, times 3. So in this case, the determinant is going to be 2 times 5 minus 4 times 3. So that will be 10 minus 12, which equals negative 2. So once you've found the determinant, there's two things that you need to sort of identify. So the thing that you need to look out for if the determinant is equal to 0. And if the determinant is equal to 0, that means the inverse does not exist. And if the inverse does not exist, that means the equation can't be solved. And the other thing is if the determinant is not equal to 0. So if it's not equal to 0, such as in this case where it's equal to negative 2, that means the inverse can be found. And if the inverse can be found, you will be using this formula. So VCA does not expect you to find inverses, or most of the time, by hand. So you will be using your CAS most of the time. So to find the CAS, all you will need to do is have your matrix and put it to the power of -1 on your CAS. And that will give you the inverse. But if not, there's this formula. It's also in your formula sheet. The formula is -1 over the determinant of the matrix, so what you've just found, and then the matrix. And the order is sort of reversed. You have D and A being flipped, so in this case, the 5 and the 2 being flipped, and the B and the C just being negative. And that's how you would find the inverse. A little bit weird, but pretty straight. But just using your CAS would make it really straightforward. Okay, so once we've found, so this is the equation, so just a practice question. Step 1 is finding the determinant. So in this case, it's 4. So since it's not equal to 0, that means the inverse will exist and that we can solve the equation. Next step is finding the inverse. So you can do this easily on your CAS, if not using just the formula. And that will give you this as the inverse matrix. Now to find the inverse, you will actually be using one of two different methods. So if the equation was A times X is equal to B, to find X, it will just be A inverse times by B. However, if it was X times A is equal to B, then X would be B times A inverse. So the order is really, really important. So in this case, it was A times X is equal to B, so therefore X is equal to A inverse times by B. So pretty straightforward, and once you do that, you should get what X is equal to. And remember, these types of questions are something that you would do on your CAS most of the time. Okay. So next, we also have simultaneous equations. So this doesn't really appear that often on the exam, but sometimes there will be situations where you will have to formulate simultaneous equations. So you probably would have seen simultaneous equations before, but essentially equations involving two different variables. So you have two different variables and you have two different situations. And then you will use matrices, so you'll convert this equation into a matrix such as this, for example. So, for example, we have A times X is equal to B. So if we were to convert these two equations into a matrix equation, all we will need to do is take the equation, so 4, so 4, 2, so those are here, and then 3 and 2 over here. So they usually run like this in the matrix. So if you were to sort of spell out the equation, it would actually just be 4x times 2y is equal to 5. And then 3x times 2y is equal to 2. If you were to actually multiply it. But we're not trying to do that. We're trying to find out what x and y is equal to. So essentially what we would need to do is, again, find the inverse of A. So x is therefore equal to A inverse times by B. And that will give you something like xy equals, let's just say, after I've found the inverse and I multiply it by 5 over 2, I get 11/6, let's just say. So what this tells you is that x is equal to 6 and x is equal to 11 and y is equal to 6. So you can also solve this on your CAS if you know other functions, but matrices are always a really good way, and sometimes your SACs and your exams will be structured in a particular way that will ask you to use matrices to solve the equation. Okay, so then we have cost matrices. So this is essentially a practice question for everyone to do. So we have a cost matrices for 3 different types of clothings. So P is the cost matrix. So A costs $14, for example, B costs $26, and C costs $9. And we want to create a permutation matrix. So I've sort of didn't tell you the whole truth about permutation matrices. Permutation matrices don't always contain 0s and 1. Most of the time it will. But sometimes it can contain other numbers as well. But the important thing to note is in each column and each row, there'll only be one number. The rest are going to be zeros. So if you're watching the live stream, I'm now going to go through solutions for this question. But if you're not, I would love it if you could pause and maybe have a go at the question before I go through the solutions. So essentially what we're doing in this question is we are marking up the price of these items, or marking down in some cases. So for example, A, we want to increase by 10%. B, we want to reduce by 20%. And C, we want to reduce by 8%. So this would be the answer here. So we have the cost of the items, and then we multiply it by the permutation matrix. So essentially the way that this would sort of be done is 14 times by 1.1. So it's, again, a little bit of trial and error. There's no specific method that you can reliably use for these types of questions. But essentially, if you have 14 times by 1.1, so if you do the sort of multiplication steps, you'll usually get to the final or the correct answer. Or you can sort of use that sort of theory of multiplication. So we'll have 14 times 1.1 plus 26 times 0 plus 9 times 0. So if we were to multiply this matrix, we'll get, you will get 14 times 1.1 as your first element. And this is actually what we want, because we can't multiply by a scalar. Because if we were to multiply this matrix by a scalar, we can't multiply by one particular scalar, because what we would be doing is essentially ending up with all of these numbers multiplied by 1.1, because we want to increase the price by 10%. So this is a smart way of doing this, so that we only multiply the number we want to multiply by 1.1. So 1.1 times 14. And if we do the matrix multiplication step, it would be row 1 times column 2. So only 26 will get multiplied by 0.8. Because 14 times 0 plus 26 times 0.8 plus 9 times 0. And in that way, only 26 is getting multiplied by 0.8. So most of the time, students can get what the scalar is going to be, but they don't actually know how to set up the permutation matrix. So that's the important skill that we're sort of going over right now. And same for the third one, so so if we were to do the third step of the matrix multiplication, so 14 times 0, 26 times 0, plus 9 times 0.92. So only multiplying 9 by 0.92. So it's a very smart way of doing it, but I would recommend using trial and error on your CAS to sort of work it out.